This is section 1.1 in our MathLinks 9 textbook on line symmetry. Chapter 1 has 3 different parts to it. Chapter 1.1 is line symmetry. So chapter 1.2 is rotational symmetry, which we'll cover next. And the last one we do is composite surface area. So the first question we started with in 1.1 was, where are the lines of symmetry for each figure? Draw a rough sketch of the figures in a notebook. Well, we already have it. And show the lines of symmetry. So since it's a rectangle, we have a horizontal line of symmetry, and we have a vertical line of symmetry. Now, some people might have said it has oblique symmetry, but the truth is rectangles do not have oblique symmetry, because when you reflect it, it does not make another rectangle. So the answer for A is it has 2 lines. It has 1 horizontal and 1 vertical. The second figure is a circle, and it's a little bit, it's a little bit different. It has horizontal, it has vertical, and it has 2 lines of oblique symmetry. So it has 4 lines of symmetry. It has 1 vertical, 1 horizontal, and 2 oblique, which is a fancy mathematical word for diagonal. And finally, this picture here only has 1 line of symmetry. It has 1 line, and it is a vertical line of symmetry. Okay, you can't cut it any other way and have the reflection repeat itself. And the 5th question says, redraw each diagram. We already have it done. Show all lines of symmetry. This one has a horizontal, and it has a vertical line of symmetry, but it does not have oblique symmetry. Question B has vertical, horizontal, and 2 lines of oblique symmetry. And question C just has 1 line of vertical symmetry. Question 6 says, which figures only have 2 lines of symmetry? So these little lines here mean that all sides are equal, which means, if you know that that's called an equilateral triangle, it actually has 1, 2, 3 lines of symmetry. So A does not have only 2 lines, it has 3 lines. This one's really tricky. This has 0 lines of symmetry. Well, it can't go this way. Right there? Well, actually, let's just double check here. Oh, it is. Oh, yeah. Look. Mine looks different on here. The answer is yes. It does have symmetry, but it only has 1 line of oblique. You can't make it this way. I don't think. Or maybe you can. You know what? Maybe you can. Yeah, it's 2 lines. See, my whiteboard's all distorted. It's all kind of, just to fit it onto my screen, it distorts it so it looks like a rectangle. But there are 2 lines of oblique symmetry on that shape, I believe. On C, you have 1, 2. Oh, that's not very good. 1, 2, 3, 4, 5. There are 5 lines of 1 line of vertical symmetry and 4 lines of oblique symmetry. Again, I got to look at my laptop screen instead of the actual screen because it looks like a rectangle. It has 1 line of horizontal and 1 line of vertical. No lines of oblique symmetry for that one. So this one has 2 lines. That's circled. This one has 2 lines. That's circled. This rectangle has 2 lines of symmetry. Remember, rectangles do not contain oblique symmetry, so E does. And then F would have an overabundance of symmetry. It has 4 lines of symmetry, or more maybe. Yes, it would have more. It'd actually go this way too, I think, and this way here, and then this way here, and then this way here. It has a whole none. It has a poop ton of lines of symmetry. So your answer for question 6 is B, D, and E have exactly 2 lines of symmetry. Question 7 asks us, if the dashed line is a line of symmetry, what does the completed diagram look like? So I'm going to reflect it. Remember, This is 1, 2, 3, 4 lines, 4 centimeters from the line of symmetry, perpendicular to. So if I was to draw that reflected point, it would be there. This one here is 2 away, so I'll put it right there. This one here is 3 away, so I'll put it right here. All we had to do after that is connect the dots, and that is the reflected image of that particular shape right there. Not very good, but it is. This one here would be here and here, and I just connect the dots to that. That would be the reflected image for that one. Sketch your drawings. So those would be the reflected images of both other halves for A and B. For question 8, copy the figure. So all I'm going to do here, I'm going to think about that distance there. I'm going to put my dot there. And then I'm going to connect that and connect that, and I have my reflected image. This distance, this distance, this distance, this distance, this distance. Connect the dots, and that is my reflected image of that particular shape for B. Question 9 asks us to draw the reflection. So for this one, it's kind of tricky because I actually don't have, I'll just go bring this over here. Actually, I'll shrink this one. Well, this is a smart move, Mr. Mac. And then bring this one over here. Now, if I was going to draw the reflected across the y-axis, this is your y-axis here, so it's 2 away. This will be point C prime. If I go 1, 2, 3, 4, 5 away, 1, 2, 3, 4, 5 away, this would be what we call E prime. I should erase that line, shouldn't I? Oh, hang on. If I make this and I call this one, just going to call it F maybe. F prime would be right here. Bring it over to there. And then A would be 3, so 1, 2, 3, A prime. And this one's 2 away, so right there. So we connect the dots and make our reflection. This is going to look terrible on this. But that's roughly my reflected image across the y-axis. We said skip 10, didn't we? Yeah, I think so. It says some regular shapes, such as equilateral triangles, squares, and hexagons, appear to show lines of symmetry when they're translated in one direction. Do you agree with, or disagree? Oh, we skipped 11 as well, sorry. Question 12. The Norwegian flag has a width to length ratio of 8 to 11. That means it is a rectangle. Does the flag have line symmetry? Explain your answer. Does it have line symmetry? How many? What kind? It just has horizontal symmetry. It just has one line of symmetry, and it's horizontal. You can't cut it this way. You can't cut it here, because if you cut it there, the flag would be, the ratio would be off. So it only has one line. I should spell horizontal, not H-O. Horizontal, horizontal. That's how you spell. And if you wanted to make it into exactly 2 lines, you could make it into this line here would have to be centered, and your flag's dimensions would have to be square. It would either have to be 8 to 8 or 11 to 11 in order for that to work. And our last question, how many lines of symmetry does it have? Is your first one a square on your paper or a rectangle? It's a square. If it's a square, factoring in colors, it still only has one line of symmetry factoring in colors, doesn't it? You can, but think of what that would look like if colors were a factor. It would be red, yellow, red, or black, yellow, black if you reflected it the other way. So factoring in colors, it doesn't work. Canada only has one line of symmetry right down the middle. Scotland, because it's a rectangle, does it have oblique symmetry? No, rectangles never have oblique symmetry. So it has vertical and horizontal. And because the Swiss flag is a square, it has 1, 2, 3, 4 lines of symmetry.